I think now we are ready to start. Everyone has joined in. Okay, so we are still on bearings. We are still solving some exam type questions on bearings, right? Okay, so and here we have this one here. Okay, now just a bit, let me just confirm something. Okay, let me just confirm something. All right, now let's do this for this one here. This question here, we need to have A there. Okay, and it's supposed to be in capital letters, so we have A there we have B, and here we have C, isn't it? Yes, we have C there, right? Okay, now we are good to start with the first one. Okay, so in the first question we are told, okay, put this in mind, okay, and please make sure if you have any question or you'd like to join us, email us with this email that I've included here on top. Okay, all right, so let's get started. So the question one, which will say question one, let's say this is question one in today's class. So in the diagram below, F is due east of E. Angle GEF is equal to 60 degrees, and angle EFG is equal to 40 degrees, as we can see in the diagram, right? Here and there. Now here is something that you need to take to mind before we start solving. When you are told a certain position is due east or due west of another position, then you need to understand it this way. You need to remember the compass in mind. Okay, so on compass you have north, you have east, right? Here you have west, and you have south there. So if a certain position is, let's say, due east of it, let's say here we have position A, right? Let's say here we have position A, and this position is due east of W. It means this point and this point, which is due east of W, it is lying on a straight line. So since it is lying on a straight line toward east, if we draw a north line at that point, which is A in this case, it will form a 90 degrees angle. Okay, so like here, this is forming a 90 degrees angle. So this is the idea that you need to get when you are told in the question F is due east of E, or one position is due west or east of it. Okay, so you need to understand it that way. All right, so let's use the same concept here on the diagram now. Okay, now on the diagram, see that you are told F is due east of we're told F is due east of E. Okay, F is due east of E. So look at where E is. E is here, right? So where is F? F is this side. Okay, which means E and F, they are on the same horizontal line. Okay, a straight line, right? Now at the point where E is, if we draw a north line like it is been drawn for us, okay, it is forming a 90 degrees angle here, isn't it? Yes. So if it forms a 90 degrees angle here, you need to remember that if you draw a north pole here, right, it will also form a 90 degrees angle there. So that's the analysis I need you to take. Okay, but for now, let's assume we don't have a north pole there, because I want you to see how I'm going to introduce it there and why. Okay, right. So let's start. So from this question, we are told to calculate the bearing of F from G. Okay, F from G. So look at where F is. F is here, right? And G is here. So which one is our initial point? Where are we? So we are calculating F from G. So we are at G, right? We are at G going to F. Now what are we going to do since we are at G going to F? How are we going to know the bearing that we want? So remember, the first thing I mentioned in the first class is you need to draw a straight line on that point where you are, okay, on your initial point. So in this case, we are at G, okay, because the question is calculate the bearing of F from G, okay, F from G. So we are at G going to F. So the first thing is you draw a north line at the point where you are, right? So here we are at G. Hope you're able to see this line, the north line that I have drawn. It should not be that long, just a small one which you'll be able to see. So let's extend it even down here. Yes, like that. Okay, so now identify the bearing you want. So the bearing you want is here. So this is our north pole that we have drawn, right? Let me just use this line here. So this is our north line that I've drawn. Now the bearing from G, because remember when I say I am at G, so my starting point is north, okay, if you remember from the first video, is north, right? So my north line is upward here, okay, this is my north line. So I'm going to start from this north, going to the line that is moving from so this line has to stretch from G to F. That's where I'm going to end. So I'm ending at this line, okay? So this is the bearing I'm looking for. This is the space between the lines that I'm looking for. Okay, right? Yes. So how am I going to calculate now this size here? Okay, how am I going to calculate this size here? So this is where now you need to introduce a north line at F as well. Okay, you introduce a north line at F. Okay, this line is bent, so let's, okay, wow, this is a north line at F as well, right? Okay, so if we have a north line here, remember what I said. Since E, we are told E is due we are told F is due east of E. That means here we have 90 as well, right? Yes. So if we have 90 degrees here, this is our 90 degrees. Okay, so if we have 90 degrees here, it means we can find the total angle from here up to there by adding 90 plus 40. And what are we going to get? That's 130, isn't it? So all of this angle is 130 degrees. Okay, so you need to keep that in mind, but for now let's just keep that in mind and assume we haven't added. Okay, yes. So the bearing we want here is this one. Okay, so what is the strategy that you need to use here? The strategy you need to use is you extend also here. Okay, this is parallel lines, and then ignore as if they are, you don't have these other parallel lines here. Okay, what I'm talking about is this. Let's do this. Have you seen what I've done here? So ignore you don't have these other lines, okay, this other part. You just have this line here, G and E. Okay, and then use the properties on the angles which are formed between two parallel lines. Okay, yes, but now this time we have it there. We're not going to cover it. I want you to get used. Even if there are 3 lines here, 3 transversal lines or 4, you need to know which ones to focus on when you are solving. Okay, so in this case we're just focusing on this one here. Okay, this one, right? Let me even draw it like that, and this one here. So just this area, these two. Okay, so before we solve for that one, now apply the properties on the angles that are formed when a transversal line cuts 2 parallel lines. How do you look at this angle here? This angle and the bearing we are looking for here, we say these are alternate interior angles, isn't it? And they are equal. Okay, so if we solve for this one here, it means we've also solved for the other angle here. Okay, and then look at this other one, this side, this one, and this one here. From here, okay, let me use the inner part, from here, okay, up to there. These are also alternate interior angles, okay, from class 1 and class 2. Please, if you haven't watched, make sure you go back and watch so that you can catch up. Okay, you need that knowledge. Okay, so what are we going to do now? So we know that this angle here, we're saying this angle, if we add 90 and 40, if we add 90 degrees, okay, plus 40 degrees, right, which is giving us 130, which is giving us 130 degrees, right? We haven't started answering A, but I'm just showing you the knowledge that you need here, how you need to analyze the question before you finally answer it. Okay, sorry, that's not 180, we are getting 130, right? So we are getting 130 degrees. Now that 130, we'll say 130 is just the angle covering 90 and 40. So 130 is all of this angle there, right? So this is 130 degrees. Okay, so if this is 130, then this is also 130 degrees here, right? Now if this is 130, then we can use the properties on the lines or angles formed on a straight line, right? How does that apply? So just here, okay, here we know that all of this angle up to here, it's 180, right? Now 180, we have been given 130. That is, if we add 90 and 40, we have 130. So out of 180, this whole line here, a straight line, we are considering just this line here. Remember, this is our north pole or north line. So we are considering this straight line here to be 180, like we saw in the introduction. Okay, so if the whole of this line, the angle is 180, this side, it means if this is 180, then out of 180 we've been given this 130. Okay, we've been given this 130. So what is remaining will give us this angle it is remaining. Okay, so to find this angle here, we'll say, let me use now the same color, we'll say 180, right? So 180 degrees minus 130 degrees, this is giving me 50 degrees, right, as an angle here. So this angle here is 50 degrees. Now remember the properties we said, this angle here, right, and this angle, they are alternate interior angles. So since they are alternate interior angles, this bearing here is also what, 50. Now because it's a bearing, we'll add a 0 in front. So A now, after analyzing the procedure in that way, then we'll say A, to solve for A, that is the bearing of F, right? The bearing of F, okay? F from, okay, that was F from G is just 180. That was 180, right? Degrees minus 130, okay, using the analysis that I've shown you, okay. Oh god. So using the same analysis, if we subtract 130 from 180, we are getting 0.50 degrees as the bearing that we are looking for, okay. If you do not still get the point, make sure you inbox and I'll be able to attend to you. But all you need to know is the properties. When you use them, you can see clearly. And if you don't want to analyze it the way I've done it, here I've shown you to say, if you add 90 and 40, okay, you are getting 130 this side, right? This 130, and then you realize that this 130 is alternate interior to this one down, okay, this one, and we said this is also 130, okay. Now we have a straight line, okay, this is a straight line, okay, passing through at G, okay. Since this is a straight line as well, you can simply say this 130 from 180, it will give you the remaining 50, which we have written here, okay. So there are so many ways you can analyze this question, so long you know the properties. Okay, let's answer now question B, that is 2, okay, this one here, E from G. Now we need E, okay, from G, E from G, right? Okay, E from G, how are we going to solve this one? Now E from G, remember that E from G, let's do this. So look at where your E is. There. Okay, your E is here. E from G, okay. So remember, you still have your G. Let me use this color, okay. Your G is still the same one, this one. I'm using blue this time. And E, you are considering E here. So even at E, let's make extend the north pole, okay, so that it forms two parallel lines, right? And now this time, ignore this part, okay. Ignore this other part that you have found. You can ignore it so that you can focus just on this part, right? Okay, so now this part, remember you are taught to say F, okay, even here F was due east of E, okay. So that tells you that even here you have 90 degrees, isn't it? Yes. So since this is 90 degrees, so this time to find this one here, so remember what we need to find. The question is asking us to calculate the bearing of E from G. So let's first identify it. E from G. So where are we? We are at G, right? We are at G. Let me just retype G here so that you can be able to see it. So we are at G, okay. So that is G, okay. So we are at G. So at G, when we draw a north pole, which we have already drawn, so it's here, right? So from G, my north pole is the starting point, is my starting point at G, right? So I'll start from G, this time going straight until I reach to the path stretching from G to E, right? So this is the bearing I am looking for, right? Okay, now to find this bearing here, I need to calculate the size of this angle here. Okay, if I calculate the size of this angle here, okay, hope you can see it, and subtract it from 360, it means I'll find the bearing that I am looking for, stretching from north to the line stretching from G to E, right? So how am I going to do that? Well, there are so many ways you can do that, right? But the simplest one I'm going to show is the one we previously used, okay, here. The knowledge that we used to manipulate the first question here when we got 130 after adding, right? So here let's also add 90 plus 60 so that we can get the total of this angle, right? So when we add, we are going to have 150, right? So 150 is the big angle, okay, from here up to there. So all of that angle is giving us 150 degrees, right? Now remember, this is a straight line as well. So this is a straight line. So if this is a straight line, then it has a degree of this angle is 180, the total, right? So out of 180 we've been given 150. How are we going to find the remaining? The remaining, you subtract 180, right, minus 150, which is going to give you, so the first step that we have to do here to consider is subtracting 180 degrees, okay, subtracting 150 degrees. Hope you've seen how we've found 150 there, minus 180, right, degrees minus 180, which is giving us 30 degrees. Now that 30 degrees is for this angle, okay, this angle which is remained there. Let me just write it properly, okay, is for this angle here, right? This is 30, but then remember that this 30 here that we have calculated and this angle, they are alternate interior angles, okay? So those two properties are very important properties of angles formed when a transversal line cuts two parallel lines, okay, right? So since this is 30 and it is alternate interior angle with this one, then this one is also 30 degrees, right? So this angle here is also 30 degrees, and because I've found this angle to be 30, so to find the bearing of E from G, I'll take the total. We know that if this one, it's a complete circle, right? If it is a complete circle, if it is just a complete circle like this one, the angle is 360, okay? This time it is incomplete by 30 degrees, which I've calculated there, okay? So to find the remaining part, we'll say a 360 this time. So now 360, which is the total angle for a complete circle, minus 30 degrees, okay, 30 degrees, that's a small angle we have calculated there, right? So minus 30 degrees, and we are going to get 330, right? So 330 degrees is the bearing of E from G, right? Okay, so let's solve the second question, okay, in the next video, right? Okay.